So read the words, and it says, in the survey, 510 adults were asked if they drive a pickup truck and if they drive a Ford. So they got two questions they asked. The results showed that 1 in 6 adults surveyed drives a pickup truck, and 3 in 10 adults surveyed drive a Ford. Of the adults surveyed that drive Fords, 2 in 9 drive a pickup truck. Those are the words, right? So the first question says, find the probability that a randomly selected adult drives a pickup truck given that the adult drives a Ford. So this is a conditional probability, right? The assumption is the given, right? Given it. What's that probability? What is it? 2 out of 9, right? It says that at the last sentence of the word, doesn't it? It says, of the adults surveyed that drive Fords. That's like saying, given that they drive a Ford, 2 in 9 drive a pickup truck. So this is simply 2/9, right? The answer is actually in the words that time. All right, how about question B? It says, find the probability that a randomly selected adult drives a Ford and drives a pickup truck. This is like selecting the 2 black socks, A and B. Okay, so the probability the person selected a and drives a Ford and a pickup truck, well, that's the multiplication rule. You don't want to lose sight of that. So if I use this multiplication rule because I want A and B to both happen, how could I expand it and write it out here? This is the probability of what? The probability that people drive a Ford times the probability that the person drive a pickup given that they drive a Ford. All they did was use the multiplication rule right there. A lot of people frowning at me.
No, I think I did it right.
Huh?
I think I did it right.
So that's the multiplication rule. That's what we just talked about. The probability that the first event happens times the probability that the second event happens, given that the first occurred. Yeah, Tyler? Yeah, where'd you get the 1/6 from? That's how many people drive what? Well, how many people drive a Ford according to the survey? 3 out of 10.
And then the second part is going to be the 2 over 9.
That comes from right there, right? That's given in the last sentence of the work. So that's 2 over 9, which equals, well, I multiply the two together, what do I get?
1 over 15.
6 over 90 or 1 over 15? Okay? So let's go down to part C, which says, are the events driving a Ford and driving a pickup independent or dependent? How do we just answer that? Well, look at the probability of driving a Ford, or excuse me, and say driving a pickup, given Ford, we know that. Is it equal to just driving a Ford? Who said no? That's correct. I think it's not. It's no, right? No. What's the probability of driving a pickup given Ford? That's 2/9. Is that equal to the probability of driving a Ford?
Shouldn't we be comparing the probability of pickup given a Ford to the probability of pickup?
Well,
That's what it means, the dash given.
No. I mean, we should be comparing it to the probability of the pickup.
oh, part of the pickup, yeah. It almost doesn't matter, but yeah, that's fine. Because when we wrote the independence rule, let me go back, it said the probability of B given A is equal to the probability of B. In other words, B doesn't care what happened. In other words, the driving the pickup could care less if it's a Ford or not, okay? So Matthew is right. So what's the probability of the pickup? And what's the probability of the pickup? Do we know that?
1 in 6 adults.
1 in 6. And are these two equal? No. Now, before we take a break, what's you know, that's important to brands, right? That says if it doesn't matter that you're a Ford or a Chrysler or a GM or a Jeep buyer, doesn't matter what you buy, they'll each sell or have the same probability of selling pickup trucks. Now, that's what independence would mean, right? Independence would mean that the probability of buying one of these pickup trucks is independent of brand. Now, just common sense says that that's not true, but these numbers are not equal. And the arithmetic shows that they are not independent. The brand, the Ford, has some influence. It has some relationship to the probability of the person purchasing a pickup truck. That's what it means. So it has immense application in terms of trying to establish your brand. You're trying to make the brand count. That makes sense, everybody? Okay, so let's take a 10-minute break, come back, and I'm going to ask you to do, I think we have problem 4. Are we at problem 4? I want you to do problem